Brief History of Endodontic Instruments. In his 1733 book, Le Chirurgien Dentiste, Pierre Fauchard described instruments for root canal preparation. The basic treatment technique at that time was cauterization of the pulp with heated instruments. At the end of the 18th century, only primitive hand instruments and excavators, some iron cauter instruments, and very few thin and flexible instruments for endodontic treatment were available. In the 19th century, enlargement of root canals was performed with broaches. In 1885, the Gates-Glidden drill was introduced. Ultramer, in 1892, described the first rotary system for root canal preparation. Fine needles with a rectangular cross-section were mounted onto a dental handpiece, passively introduced into the root canal up to the apical foramen, and then rotated. Interestingly, in 1889, William H. Rollins had designed an endodontic handpiece rotating at low speed of approximately 100 RPM and with a 360 degrees rotation, similar to the motors used today for canal preparation with needy instruments. In the first half of the 20th century, techniques such as iontophoresis, using electrical current, gained some popularity. From the second half of the 19th century, coarse instruments were created from piano wires in order to allow the removal of tissue remnants from the root canals. But in 1904, Kerr Manufacturing Company, Romulus, Michigan, manufactured what can be considered the first true endodontic instruments, the K-type files, K-files, and K-type reamers, K-reamers. A third type of root canal instrument is the H-file, shaped like a wood screw and developed in 1940 by the Swedish company Sendelin in collaboration with the Swedish Dr. Gustav Hedström. For years, files and reamers were manufactured in carbon steel and numbered from 1 to 6, where each consecutive number was bigger than the preceding one. However, each company had its own way of producing the instruments, and there was no correlation between the different brands. In 1955, Engel called for the standardization of endodontic instruments, and he officially proposed the idea at the Second Conference of Endodontics held in Philadelphia in 1958. This standardization set specific dimensions for the tip, D1, and the top of the cutting portion, D2. From the start, despite the reluctance of most other companies, the Swiss brand Mailfer embraced this project, inventing and manufacturing the first testing machines and quickly becoming the market leader. In 1961, the publication of Engel's seminal article, A Standardized Endodontic Technique Utilizing Newly Designed Instruments and Filling Materials, was a turning point in the endodontics field. Engel advocated replacing corrodable carbon steel with stainless steel, refined the standardization of instruments with the addition of a 0.08 file and of larger ones from 110 to 140, and implemented a color coding system. A new standardized technique was proposed, thanks to the matching of the new standardized shaping instruments and filling materials. It is interesting to note that at that time, more attention was paid to filling than to effective cleaning and disinfection. In 1976, the Council of Dental Materials and Devices of the American Dental Association, ADA, approved the specification number 28 for endodontic files and reamers. In this specification were included Hedström files, number 58, rasps and barbed broaches, number 63, probes, applicators, condensers, and spreaders, number 71. The materials used were carbon and stainless steel. Details regarding dimensions, sampling, inspection, and test procedures were given. These included diameter, taper, tip length, resistance to fracture, stiffness, and resistance to corrosion. Later, a group of experts from Fédération Dentaire Internationale, FDI, the World Health Organization, WHO, and the ADA created a committee as part of the International Organization for Standardization, ISO, to elaborate international norms based on the ADA's initial work. Both ADA/ANSI, American National Standards Institute, specification number 28 and ISO norms are updated on a regular 5-year basis. Thus, work is in progress on root canal shaping instruments for the ISO 36301. 2019 Specification Dentistry, Endodontic Instruments, Part 1, specifying general requirements and tests methods for endodontic instruments and covering general size designations, tolerances for all design features, color coding, packaging, and other details. At the end of the 1980s, a promising idea was developed to substitute stainless steel with nickel, titanium, needy, alloy in the manufacture of endodontic hand files. These files were supposed to be 3 times more flexible than their counterparts in stainless steel, and also to be more resistant to torsion. But they turned out to cut much less, and to have a tendency to break without warning. It was later realized that, due to their flexibility, the traditional filing motion was a drawback, as was the standardized technique of placing all files sequentially at the working length, which promoted a taper lock effect. However, it has since become possible to use them as engine-driven instruments, making them more efficient and increasing their taper. The Quantec and Profile, both featuring radial lands, are good examples of the 1990s era. Notably, the Profile system developed by B. Johnson was the first mechanized system to advocate a pure crown-down technique. In 2001, the innovative and patented ProTaper system was designed with sharp edges. This was the first to feature a working portion with variable, i.e. increasing and decreasing, tapers. Some years later, it became clear that the only way to further improve the behavior of these instruments was to work on the properties of the needy alloy. Thus, in 2007, M-Wire, the first needy heat treatment, significantly increased both flexibility and resistance to cyclic fatigue. This was followed by the launch of the twisted files, with a specific heat treatment used to identify the phase, allowing them to be twisted instead of being ground. Since 2010, several more technological advances have emerged. A new shaping technique using reciprocation with only one instrument, Wave 1 and Reciproc Dentsply Sirona, a self-adjusting file, SAF Redent, with an innovative structure and new needy alloys, CM wire, Coltine, blue and gold heat treatments, Dentsply, electrical discharge machining, Coltine, and most recently, needy shape memory by FKG, XP Finisher and XP Shaper. For a review of the new thermomechanically treated needy alloys, see Zipank et al.